very strong contender as a sustainable additive to decarbonize multiple industries in the future. So, to give you a perspective about what graphene is, so graphene is basically a carbon-based nanomaterial, right? We already have a lot of carbon nanomaterials like carbon nanofiber, nano activated carbon, as well as carbon nanotubes. So graphene is again one of the member of that family, I would say. But there are quite a lot of possibilities with this material when compared to the other materials out there. So it has quite a bit of interesting properties, which makes it a good fit for a lot of use cases. So the idea is, how do we use it to improve the sustainability of existing industries? So this discussion is all about our effort in how we can basically catalyze the use of graphene in industries such as construction, paints and coatings, as well as batteries. So and to begin with, our primary focus as a company is basically to decarbonize construction, right? And the reason we are focusing specifically on that industry is that cement and steel are the most commonly used raw materials for construction. But as you could see from the figures, it contributes to more than 60% of the global carbon emissions. Besides that, the water use of this industry is again quite high. When you look at every 10 liters of water consumed, 1 liter of industrial water consumed goes into construction, right? So there's a lot of natural resource being used in construction, but it could be more efficient. So we are trying to change that. So especially since carbon emission is directly correlated to global warming, a methodology to cut the use of these kind of carbon intensive materials can basically help us steer towards a more sustainable future. So that's exactly what we are trying to do with adding graphene in construction. So and the reason why we are using graphene specifically for construction is that theoretically and experimentally it has been proven that it's a material which is 200 times stronger than steel, and it has exceptional barrier properties. It is chemically resistant to all types of alkalis and acids. In addition to that, it has excellent mix of thermal as well as electrical conductive properties. Because of that, this looks like the perfect additive to revolutionize a lot of these industries. And to prove that, we set out to use this as an additive for construction. And here what we had tried to do is basically develop a top-down based manufacturing process, right? So we know that this material has a lot of scope, but it does not end there. Basically, we need manufacturing platforms to scale up the manufacturing to a level where it can be available at a competitive cost to industries. So that is exactly what we set out to do. So basically what we did is we had built a platform from ground up, where right from the manufacturing process to the use of raw materials, it is indigenously developed in India. For the first time, what we've done is we have developed the top-down manufacturing model for graphene, where using commercially available graphite powder and a few other proprietary additives, we had developed the exfoliation-based strategy with which we can disperse graphene in a range of solvents and oil. So basically, graphene dispersed in water can be used directly for concrete, and graphene dispersed in solvents and oil can be used for other use cases. So basically, this is a exfoliation platform with which we could build up to 50 use cases, spanning multiple industries. So this platform is proprietary to the organization, and it's part of a patent family which we have filed, for which basically covers both the manufacturing process as well as the chemicals involved for the manufacturing. And the reason why we are excited about this, this additive specifically is that, this one additive, when used at a weight percentage of 0.2 with respect to cement, can positively influence up to 6 properties in concrete. So for traditional construction, M30 is the most preferred design mix. M30 is a grade of concrete which refers to the strength. So in a traditional M30 grade concrete, adding 0.2 weight percentage of terracops graphene basically helped us reduce the water permeability and chloride ingress. Basically, these are two parameters which directly correlates to how good the reinforcements durability would be over an extended period of time. So basically, the ability to reduce water permeability as well as the ability to reduce the chloride ingress inside the concrete structures will basically enable improved lifetime of the reinforcement rebars, which will basically prolong the lifetime of the concrete structures. So this is one way by where we can cut down the CO2 emissions. And the other model is without increasing the cement content, by adding this additive, we can influence the strength as well. So right from the compressive strength, flexural strength, as well as impact strength, all these three parameters can also be influenced. So all this is possible with just one additive, right? So the possibilities that it brings forward is large, provided we have a cost factor which would be able to match this industry, which is a commodity. Again, cement is something that we can source at 400 rupees for a 50 kg bag. So considering that, we set out to develop a manufacturing platform which would make it compatible to be used in this kind of a commodity industry. And what we have been able to do is, when we look at the cost of cement that will be saved by using this kind of additive, we are able to achieve this improvement with only a 5% incremental cost, which is again very much viable for use in this industry. And the second thing that we focused on is the entire model of developing a water-based admixture is when we started out this company, we intended to be a graphene powder manufacturer, but then we soon enough we realized that graphene powders use is again very limited. So a material which has a very low bulk density cannot be incorporated easily if there is no adequate expertise at the customer's facility. So what we set out to do is enable a frictionless incorporation model where basically the water-based admixture can be directly introduced during the casting process. So basically a layman with very little expertise can use our product. So which I believe could be also a catalyst for adoption of our product across geographies without much friction from the customer side. So the possible use cases that we are looking at for this industry. So pertaining to concrete, two industries that we are focused on currently is precast concrete, because again we are moving towards an economy where resource utilization should be high. So basically to minimize waste and to improve repeatability, so precast is something which is more sought after in the industry today. So since it is a more calculated approach and where the raw materials quality is again monitored closely, precast is one market where we think we can bring a lot of positive developments. And in addition to that, the second model is basically using graphene on site for realtors and other commercial establishments who are interested to reduce the carbon footprint. So this is one model where we have come up with mixed design, where we have figured alternatives for both the three common ingredients: cement, fine aggregate, and coarse aggregate. We have basically replaced the raw materials in this mixed design with industrial waste raw materials, which can be sourced from our facility. So currently our facility is based in Coimbatore. So we have built a library of industrial waste raw materials which are available in excess of 50,000 tons per year. So based on a funnel that we have created, we have come up with a mixed design wherein a cost-efficient and a low-carbon concrete mixed design has been developed. And since in traditional cases, when we use that kind of waste materials, there is a substantial reduction in performance, or to be more specific, the strength would substantially decrease. But considering we are using graphene to increase the strength, it is able to benchmark the commercial M30 additives strength and other characteristics. So this could be a more viable model for reducing fresh materials usage, reducing the carbon footprint, as well as to increase the adoption of materials like this in this industry. And this is the first time it is being demonstrated in India. So what we plan to do is, considering that we are in the climate tech space, our idea is to see how we can reduce the carbon footprint. Right? So basically, the main metric that we work towards is how much CO2 emission can we mitigate per m³ of concrete. So by basically saving the amount of cement used, water used, as well as the aggregates that is used from the traditionally used concrete structure, we are able to reduce at least 25% of the CO2 emissions per m³ of concrete. So with this model, with the manufacturing, if we are able to manufacture 1,080 tons of graphene, it can be used to mitigate 5 lakh tons of CO2. So which we plan to do in the next 5 years. And the most interesting part is the carbon footprint. So this is one place where I think we have a real differentiation. So far the conventional manufacturing processes has involved energy intensive processes for graphene manufacturing. So what we have pioneered is instead of building something from ground up, we have taken commercially available manufacturing processes and modified them to specify to the requirement that we actually have. So by using that model, all the raw materials for this manufacturing process is available in within India, and the process and the energy cost involved for manufacturing is also substantially low. Because we do not use plasma-based model or acid-based model, which is traditionally used in graphene manufacturing. So by following that methodology, we are also able to reduce our carbon footprint in manufacturing, which basically translates to a very good impact when it comes to the value of use case being translated to the end industry. So basically, for every 1 ton of CO2 that we emit, we would end up saving 90 tons of CO2 when our graphene is used in concrete. So for this, we did a thorough life cycle analysis throughout the value chain to understand what are the raw materials, carbon footprint, and their intensity, and then we figured this value. But this is just the tip of the iceberg, right? So the most interesting aspect I would say about graphene is, it's a I would say this is going to be the nanomaterial which is going to change the world as we know it. Because as you could see, the use cases are across the horizon. Everything right from biotechnology, biomedical engineering, composites, printed electronics, and coatings. It can be used literally everywhere. So that is one thing why we are very fascinated about what we can do for other applications as well, in addition to concrete. So there are a few other applications that we are currently working on. So, but beside that, what I also wanted to talk about is how graphene can be used to mitigate CO2 in other industries. Right? There are few real-world applications where graphene has been used and demonstrated for its CO2 mitigation potential. So I have enlisted 3 examples of commercially available products as of 2023, which are on sale right now, and which basically proves what can be done when a robust manufacturing platform for graphene is available. So the first example is basically from a company called Applied Graphene Materials based in UK. So what they've developed is basically a bisphenol A based epoxy primer. So it's again very similar to a commercial epoxy primer that's available in the country. But the only differentiation factor is that they have figured out a way to incorporate graphene into their epoxy resin. So basically, by incorporating graphene effectively, they were able to improve their anti-corrosion properties 5 times. So basically, this kind of anti-corrosion primer is again very sought in industries where seawater is concerned, especially for sea hulls. This kind of ships where which has a lot of time spends a lot of time in the sea. This kind of corrosion coatings are basically preferred, and there the life cycle of the paint can be improved by adding this as an additive. So in addition to that, again there has been another use case by MSI Corporation where they've used it with a graphic card. So basically, what they've done is they've compounded graphene using the traditional compounding process used in the plastic industry, and basically ended up improving the thermal characteristics. So basically, there is not a substantial change involved. So the polymer compounding process remains the same, but when there is an effective model or methodology to compound graphene into the polymeric compound, there we can observe a 20x better heat dissipation. So better heat dissipation directly can be converted to better thermal efficiency. So which means that the energy savings could be substantial when we would consider using this kind of graphic card. And again, the third example would be energy storage, which is again something of very much relevance today. So Flash Pro is again a power bank developed by a company based in USA. Which actually has it's again lithium ion based chemistry, but the conventional lithium ion based power banks usually have around 500 to 700 cycles, but using graphene in their cathode, they are able to improve their cycle life by 4 times. Basically, they have data which claims that there are this charger can go around 2,100 cycles. And also, again, the other challenges with lithium-ion is again of safety. How I mean, that is another place where graphene plays a key role. By basically using this as an additive either in anode or cathode, we could basically reduce the internal resistance of the cell by around 3 to 5 times when compared to using just the active metal-based active materials. So by reducing the internal resistance and also by using it as an additive in electrolyte, we can basically make the available lithium-ion cells more safer. So these are few areas. I mean, again, there are other areas that we are focusing right now, but this is again few areas I want to bring forth to show you guys about what potential this kind of metal can have. So yeah, so that's about it. I will be happy to take questions. If you have any questions, you can drop me a mail.